So by now, using the DMAC approach, we defined the problem, we measured the performance of that, we analyzed that, and we improved that. In the last phase, which was improve phase, there we even did cost benefit analysis because we wanted management approval for those changes. So all these things have been done now. So what is left now is the control phase. In DMAC, the last part of that is C, which is control phase. This is the important phase of the project because this ensures that whatever changes you made, those changes stay. Because if you don't put controls on those changes, there is a good chance that people will go back to the old process, things might start again going down. So that's where control phase comes into picture. For that, one of the important tool is control plan. We make control plan to ensure that whatever changes we made, those changes stick, those changes remain. Important thing here is that when you make a control plan, make sure that you engage the process owner, because end of the day, that person, the process owner, is the one who will be running this process. So make sure that when you make the control plan, the process owner is involved in that process of making the control plan. Control plan, just like any other document, goes through the review and approval process, and this is revised from time to time based on the feedback or the lessons which you learn. So here this is an example of a control plan for wooden chair manufacturing. I have put a very simple example. Let's say I'm making a chair, and for that I need to make legs, I need to make the seat, I need to make the back of that, and then these are the steps, these are the controls which I want to be in place. So let's look at the first row, which is chair leg length control. Probably there was an issue related to chair legs not being equal, and because of that chair was not balanced. So here the control plan is set up to make sure that all the 4 legs of chair are of equal length. So that's the first step. Here it gives all the details such as what is the machine used here is a saw, what is the specification characteristic is the length of that piece, length of the leg, and it gives the upper and lower specification limit, which tells that how much longer and how much shorter this leg can be. So this leg can be anything between 49.9 to 50.1 millimeters. That's the length of that. How do we measure that? Using measuring tape. Sample size is 100%, so we measure each leg, and the sampling frequency is 100%. The measurement is done by the operator, and operator records that on X bar R chart. So that is the place where operator records this dimension, and then there is a procedure reference for that, and there is an action plan. If something goes wrong, then what this operator needs to do. So all these things related to each of these critical characteristics is listed in this control plan. So this control plan now helps you in keeping you on track. So whatever changes, whatever improvements you have made, this control plan will help you in keeping those changes on track. So this was the control plan.